Here is the CNC-STEP machines electronic controller for the stepper motors. This model is the version 1. This is the very early versions. And here I show what I did the modifications here. First is it always burns in the rectifiers, down rectifier. So I had mounted it on this aluminum plate. So originally it was here, and there is no heat sink for this dial, rectifier dial, and it burned this because there is much heat on it. So I mounted on this aluminum plate, and also some heat transfer grease was added for better heat conductions, and the big one connect back to this circuit board. Another thing is the high heating on these 4 motor drivers IC. Originally there is small heatsink here and the fan heat, and I additionally increased the size of heatsink by adding a aluminum plate here, and also this plate connect to this large aluminum plate here, and grease also add in between it. These 2 aluminum plate was added. Finally, for this circuit board, underneath on the bottom side of this circuit board there is the copper tray. For the copper trays of the for the power line, there is the DC positive and DC negative power line. I removed the top coating surface, and the copper was exploded, and I found the copper tray thickness is too thin. So on the surface of copper trays for these power lines, I add the solders on it. Thanks for your watching. You can refer to later photos for the illustrations of it. I showed you the further modifications of the stepper driver controller of the CNC-STEP. To incorporate the using of 5th axis, the motor driver need to be upgraded. This motor drivers originally have the 4th axis controller, stepper controller. But I don't want to use the originally the 4th axis controller here. this board. This main board is the 3-axis, because I don't want to use it because my stepper driver is a little bit smaller than this machine stepper driver motors, and when I use this controller, the motor will be heat up as the currents drawn by this driver is a little bit higher than what I need. So instead of this, I need to add 2 stepper driver. This one is for the 4th axis, this one is for the 5th axis, and this driver used the newest Toshiba's TB6600 IC driver, and it is better than the previous ones because there is a selection for the current, so I can choose different types of currents to suit my starter motor. Here I choose 1.8 amps or 1.2 amps for the use. And I further need to investigate this. If I use one more stepper driver, I need to check if the transformer, it will be heat up, or if it has sufficient powers for drive additional axis. And I disconnect the power to this original 4th axis. And in doing the 5th axis, I need to incorporate the second parallel port. Of course, if you use the USB smooth steppers, that there is no need to do that, but I use the traditional one's parallel port. I add the second parallel port. It's better to have a second breakout box, but I simplify the method, so I directly incorporate the parallel port. And in doing so, I need to do some additions. And here I add for those pins, I add the pull-up resistor for them, and for the additional two limit switch, I need to add 0.1 microfarad capacitor on the two end switch. And you can see here the yellow one is the small capacitor, and the other is the pull-up resistor. And I also add a power switch for these two stepper driver. When I don't need the 4th and 5th axis, I don't turn on the power for them, so I can save some power. That's all. And also these two sockets is for the 4th and 5th axis, and this sockets, which is originally the 4th axis, I converted to the sensors for or end switch for the 5th and 4th axis, and the rest, this 5-piece black color sockets is remain the same. That's all the changes I made on it. Thank you for your watching.